Today we are going to discuss what are the classes, what are the objects, okay, and
Okay.
what are the concepts of object-oriented programming. So in C++, Java, we have object-oriented concepts, right? In the same way, in the Python also we have object-oriented programming concepts, right?
Okay.
So
Yeah.
today we will discuss what are the features of object-oriented programming one by one, and later we will see each concept programmatically. Okay. So
Okay.
first thing is class. What is a class? If you see the definition, a class is a blueprint or template for creating objects, right?
Yes.
So in general, before implementing any object-oriented programming, before implementing any real-time project, right? We will first identify what are the objects we have. Like object means it may be a person, like employee. It may be a bank account. Bank account is also one object. Okay. So before implementing any object-oriented programming related projects, first we will identify what are the objects we have. For each object, what are the features it will going to have. Okay. So for that object, what we need to do is first we need to create a class. Let us say in our example, I have considered product as a class. Okay. So inside the product, first I will create what are the variables we need to have and what are the functions we need to implement. First, I will prepare a blueprint. Okay. So for a product, uh, what are the details we generally store? Product name, its price, quantity, correct? And some
Yes.
functions which operates on these variables. Let's say total price of a product. If you want to display, you can write a display function. If you want to do some discount related calculations, then you can introduce a function called discount. Okay. First, before creating any objects, I will create a class in which I'll mention all the required details, like what are the variables we need to have and what are the functions we need to implement. So this is what the blueprint of an object. Class is a blueprint of an object. That means it will not be stored inside the memory until you create an object. No memory is allocated for a class. So that is what a class is called, a blueprint of an object. So it is a plan what we are going to store inside an object. All the details we will mention in a class. Understood? So this is
Yes.
what a class. It definition is a class is a blueprint or template for creating objects. Okay. Then coming to an object. What is an object? Object is an instance created from a class, like a physical product created from a product design. So simply we can say object is an instance of a class. When we create an object, actual memory is created in the system. Until you create an object, no memory is created. Even though you create multiple classes, no memory is allocated for it. Okay. Only the memory is available or created once you create an object. So in our example, I have created two objects. What are those? P1 and P2. Okay, product is a class. For the product, we are creating two objects, P1 and P2. So first, let us understand what is a class and what is an object at high level. Then we will see how the memory is allocated for an object. Okay. So here I have shown you how to create an object for a class product. Okay, how many objects we have created?
Two
Two
objects.
objects we have created. So internally, memory is allocated for the objects P1 and P2, right? Then coming to the next concept or next feature of object oriented programming is attributes. So attributes means the data which we are going to store inside an object are called attributes. Okay, so in our example, how many attributes we have for a product class? There are two attributes, name and price.
Right.
Okay, so let us not focus on other details. Let us only focus on what are the attributes. Here we have two attributes. What are those? Name and
Name, price.
price. So basically these are the variables in which we are
Mm.
going to store some values. Okay,
Yes.
so here product is a class. If I create an object for a product, inside these object we can store two values. What are those? Name of a product
Mm.
and price of a product. Okay, so this is our class. Product is a class. Inside this we have two variables, name and price. So these two variables are called attributes of a class. Attributes of a class. So what is the purpose of creating attributes? To
To
store
store
some
values.
values. Okay. So in this example, we have created only one object. What is the name of object? P is the name of an object. P is the name of an object. And we are creating this object by sending two parameters. What are those? Laptop and 55,000 is the price. Okay. So these two values are going to store inside attributes, name and price. Okay. So there are other details which we need to discuss. That is a constructor. What is a constructor and other details? We will see later those details. Okay. Then coming to methods. These are all methods are called object functions. Why methods are called object functions? We will discuss. First, let us understand what is a method. Okay. So method is a function which is defined inside a class. Any function you define inside a class, that is called a method. Okay. In object oriented programming, generally these are called member functions. Member data. Member data means attributes. Member data means attributes. Member functions means the functions which are defined inside a class are called member functions. If you define any function outside the class, you should not call it as a member function. Okay? Member function means it should belong to class. So in our example, we have a one member function, that is apply discount. Apply discount is a function which is created inside a class. So you should call it as a member function. And also you can call it as a object function. Why it is called object function? Because this function should be invoked with the help of an object. Okay, if you want to execute this function, first you need to create an object, then with the help of that object you can invoke this function. So these are all called object functions. Okay, so in our example we have one class called product. In the product we have two attributes, name and price. These are the two attributes. Then we have one member function called apply discount. Inside this member function we are doing some calculations. Okay, we are calculating the discount. So then in the next cell we have created an object. P is an object. Okay, then with the help of an object we are invoking the member function P dot apply discount, and 5 is a parameter. Okay, so again I will come back to these examples and I will execute, and I will explain what is happening internally. Okay, first let us understand what are the features of object oriented programming. That is our first focus, right? Then init. Init is a function which is defined in the class. This is called a constructor. Okay, the syntax is this one: def underscore underscore init underscore underscore self, and if there are any parameters we will specify here. Okay, so this is called a constructor. Okay, so constructor, what is a constructor? As its name indicates, it constructs the object, correct? Constructor will construct the object. So whenever you are creating an object, something like this, you are creating an object, then internally the system will execute a constructor. So this function is executed automatically whenever you are creating an object. Okay, then internally what will happen means it will create a memory for the object, and it will store the values inside the attributes name and price. These are the two values that are stored inside the object P. Okay, so now we understood what is a class, what is an object, what are the attributes, what are the functions. Okay, then what is a constructor, what is the purpose of a constructor? The purpose of a constructor is to create an object. Okay, it will create a memory for an object. It will store some initial values inside the object, right? So then coming to the next one, self keyword. What is self? Self is an object or a reference which refers to the current object. So what do you mean by current object? Let's say if I have two objects, let's say P1 and P2. I have two objects, right? These are two objects. If I invoke P1 dot apply discount, P1 dot apply discount, then it will invoke this function. Here also you have a keyword called self. Okay, self means what is the current object by using which you are invoking this function. So in this case, what is your current object?
P1.
P1 is the current object. So self refers to the current object P1. So self dot price means it has to get the data from the object P1. Inside P1 you will have a price. That price you are going to use. Okay. Similarly, if I invoke the same function by using P2 dot apply discount. Okay. Now what will happen? You are again invoking the same function. Function is same, but the object you are using is different. This time you are using P2. So now self dot price means this is a value from object P2, right? So I hope you understood. Once again, I'll come back to this point and I'll clearly show you how this is going to work. Okay. First, try to understand the concepts. What is a self? Self refers to the current object. Okay. Self is a variable which refers to the current object. Then the next concept is encapsulation. So encapsulation means binding or bundling data and methods together inside a class. See, in this example, we have two variables, name and balance. In the previous example, we have two variables, name and price, and one function. What we are doing here, we are bundling or grouping together the variables and the functions inside a single class. That is a concept of encapsulation. Encapsulation means combining or bundling methods and attributes inside a class. That is called encapsulation. Okay. Then the next concept, abstraction. So abstraction means general meaning of abstraction is hiding the internal details. Okay. So the user does not need to know what is happening internally. Let's say if you take a general example, car. Okay. So when you drive the car, when you rotate the steering, the direction would be changed. Right. But what is internal mechanism, how it is going to work, the driver need not to know. Correct. So certain details are hidden from the user because the user really does not need to know. Okay. So that is what abstraction. Abstraction means hiding the internal details. Okay, we don't expose everything to the user. Right. Then the next concept is inheritance. Inheritance means you can use the properties from one class to another class. Let's say in this example we have two classes. Person is a base class and the salesperson is a derived class. Okay. So whatever features or whatever attributes and functions you have defined inside the parent class, they can be automatically accessed to the derived class. Okay. So in this example, person is a base class, salesperson is a derived class. Okay. So whatever common features that are there, we will create one base class. Inside the base class, we will mention all the common features, and those features are used in the derived classes. So let's see in this example, name is a feature which is defined inside the parent class. The same name we can use inside the salesperson class along with additional details. Here target is additional feature we are added. Okay. So basically inheritance means accessing the properties from one class to another class. So here I have mentioned allows one class to take properties of another class. Okay. So in general, when we are implementing object oriented programming, what we do is we will create base classes with the common features. Okay. Let's say if you consider bank accounts, banking system, you have different kinds of accounts, current accounts, right? And a salary account, different kinds of accounts. So we will create one base class with the name account, and in the account class we will create common features. Then from that class we can create different subclasses like current account, salary account, and other different kinds of accounts we will create. So what will happen, whatever features you have defined in the parent class, they will be automatically access to the derived classes. So you need not repeat the same features in each derived class. Okay. So that is what the concept of inheritance. Then coming to the next one, polymorphism. So in general, poly means many, morphism means forms. That is what the meaning of polymorphism, many forms. That means you can use same method name with multiple signatures. Signature means multiple parameters you can use. Okay. Similarly, you can use operator overloading, function overloading. These are all comes under polymorphism. The simple example I have given here, same method we are using with a different behavior. Its functionality is different. So payment is my base class. Inside this I have a method called pay. And I have two derived classes, cash and card. So we are inheriting from same base class, payment. But if you see the definition of a pay method, so here card payment is different, internal processing of card payments are different than the cash payments, correct? So whatever business logic that is apt for the cash payments, we will implement over here. Okay. So whatever business logic that is required for processing the card payments, we will implement over here. But the function name is same, but based on the context, its definition is being changed. If it is a cash payment, its implementation is different. If it is a card payment, its implementation is different. That means the same function is behaving differently based on the context, based on the class we are using. So that is what a polymorphism. We are using the same method, but its behavior is different based on the context and based on the uh, methods or based on the classes in which we are using. Okay. So this is a simple example to understand what is a polymorphism. Okay. Then class variables and instance variables. So what are the class variables and what are the instance variables? Okay. So wherever you come across a word called instance, instance means an object. Okay. So object variables, instance variables means object variables, class variables, two types. So class variables means these are the variables which are common across the objects. These are the variables which are common across all the objects. Okay, they are the class variables. Let's say if you create a class for employee of an organization, if you create an object, if you create a class, okay. So inside that class, the total number of employees is a variable. If you take total number of employees is a variable. So that is same for all the objects, irrespective of a number of objects. That particular variable is same. There are 500 employees in an organization, so that is a constant, that is same for all the objects. So such kind of variables we create as a class variables. Okay, I'll show you clearly how to create class variables, how these variables are going to store. I will show you with the graphical representation. Okay, first try to understand what is a class variable, what is instance variables. Class variables are the variables which are same for all the objects. Okay, instance variables, these are the variables which are uh, only, which are different for different objects. Let's say if I create employee 1 details are different to employee 2 details. Employee 1 name and age and other details are different from employee 2 details. Employee 1 ID is different from employee 2 ID, correct? So these are the variables which are dependent or which are only belongs to a particular object, correct? They are not common to all the objects. So such variables are called instance variables. Okay. Then the next one, when you use multiple classes, you can use a object of one class inside the another class. Okay. Then you can say there is a has a relationship. So in our example, I have created two classes. Customer is one class, order is another class. Okay. So in the order class, I have used customer object and also product object. What is customer and what is product? These are the two objects for two different classes. What are those classes? Product is one class and customer is another class. These two objects I want to use inside another object or another class, that is order. Okay. In general, if you think any, if you take any order, it should have product information and customer information as well. correct? So when you use objects of different classes inside another class, then you can say there is a has a relationship, correct? Order has a customer, order has a product, correct? So we are using object of a customer class, object of a product class inside the order class. So you can say there is a has a relationship between the classes. Then this is a example which tells you all the details, whatever we have discussed so far. All the details I have given you one simple example. Okay. Now I'll come back to the programmatic explanation. Okay.